Hi there, it's Professor Shannon Gracie. We're on chapter 11 right now, which is talking about solving really all about quadratic equations and functions. So what we start with is solving using the square root property and completing the square, and we also learn about the distance and midpoint formulas and the Pythagorean theorem as well. So here we go. Why don't you guys go ahead and pause the movie warm up by solving these two problems in the ways that you are used to, and check back and see how you did. Good luck. Okay, let's see how you did. In this first one, it's a little bit tricky, right? With the methods that we've officially learned, you would need to multiply this out because we need to use the zero property. So we'd have to multiply it out, get 0 on one side, refactor, all that good stuff. So we'll have x squared minus 2x's plus 1 when I expand that binomial that's being squared. That's equal to 4. Subtracting 4 from both sides. I don't like that dot that I have there. Okay, so this would be x squared minus 2x, and then if I subtract 4 from both sides, I'll get minus 3 on there, and I'll get 0 here. Factoring, I'll have x minus 3 times x plus 1 gives me a product of negative 3 and negative 2 when I combine like terms for the coefficient. And then using the zero property, x minus 3 is 0, or x plus 1 is 0. So we get x is 3 or x is negative 1. And so that will be our solution set. I will leave the checks to you in this chapter. All right. So how'd you do on that one? Awesome. Okay. Now over here, x minus 5, the quantity squared, remember, means x minus 5 multiplied to itself 2 times. So we just need to solve this once. We'll get the same answer 2 times. So we'll get x is equal to 5. So our solution set is 5. And it turns out that you can say that it's a 5 with multiplicity 2. You'll learn that in pre-calculus. All right. So, moving right along, we go into the square root property. My apologies, I have an extra little line here. I'll just scribble that out. So here we go. If u squared is equal to d. So u is some algebraic expression and d is a non-zero real number. Then you get two possible results. U can be the square root of d, or u can be negative root d. So similarly, you can say if u squared equals d, then u is equal to plus or minus the square root of d. So if you recall, if you consider what we've learned previously in chapter 7, when we were dealing with x could be any real number, if you had like the square root of x squared, that would equal to the absolute value of x. This was before we were in the complex numbers. Okay? So basically, here, consider if you have something like x squared is equal to 16. Well, what we're going to learn about is we can square root both sides of the equation. So what we would get as a result on the left side is the absolute value of x. What we get on the right side is 4. But if you remember from your absolute value equation solving, that means that x could be 4 or x could be -4. And that's just what we saw up there in a more abstract format. All right? So here we go. Your author tends to give results in terms of plus or minus and not emphasize the absolute value. So I'm going to, go ahead and follow through with what the author does. So here, applying the square root property, we have x can be good plus or minus 3. So we would do our solution set as -3 or +3. And if you check that solution, you'll see that they both work. Now with this guy, we need to get the squared term by itself. So if I were to add 10 to both sides, I would have an equivalent equation. And then dividing both sides by 2, I would get x squared is 5. Square rooting both sides, I will have, good, x is plus or minus √5. So our solution, whoops, that was a little crazy. Our solution will be -√5, +√5. Okay. Again, now we're in the complex number system. So if it's okay to have negatives under the radical. So if I subtract 49 from both sides, I'll get 4x squared is -49. X squared will be -49 dividing both sides by 4. And square rooting both sides of the equation, we get, good, x is, what am I going to get here? I'll get my plus or minus, and then I'll have, remember I'm going to have an I because I have that negative in there. So I'll have 7/2 from the 49/4, and then I from the -1 that's under the radical. So you get two answers. You get -7/2 I, +7/2 I. And sometimes people put those in as plus or minus into this actual, sometimes into the actual solution set. But typically, so I'll write both ways. We could say or plus or minus 7/2 I and so this one would be, just give the alternative way of writing it. I'm not sure how the MyMathLab takes the solution. So this would be plus or minus 3. I really am not a huge fan of the plus or minus because it seems to me that a lot of people forget that there's two solutions that represents. So I kind of prefer, to write it the first way that I wrote them. But I would take both results on a test. Okay. So here we go. With this one, you have to look at it a little more carefully. Now, the cool thing about this is that if you can factor one side of it and you have a constant on the other side, you can go ahead and do that. You don't need to get 0 on one side now that you know the square root property. So if you notice, this factors as x minus 5, the quantity squared, and that's equal to 1. So if you square root both sides, you get x minus 5 is equal to plus or minus 1. So then what will happen is if you make it into the two equations, it might be a little easier to keep track. but you would get x is 6 or x is 4. So your solution set would be 4 or 6. Okay, so for part E, if I were to divide both sides by 3, we'll have x plus 2, the quantity squared, is equal to 12. And then we square root both sides. And we'll have x plus 2 is equal to plus or minus. Now the square root of 12, remember, a perfect square is in there. 4 times 3 is 12. So we can pull out a 2 from that 4, and we're left with root 3. So then, if I subtract 2 from both sides, we'll get x is equal to negative 2 plus or minus 2 root 3. So our solution set would be negative 2 minus 2 root 3, negative 2 plus 2 root 3, or negative 2 plus or minus 2 root 3 in the roster notation. So either one of these is fine. All right. So now sometimes we have to do a little more work before we before we can apply the square root property. So there's a technique. You're going to use this a lot in your future math life. Completing the square is very useful for when we're very soon going to be learning how to graph quadratic functions using the vertex. So completing the square is very useful. So I guess what I'm saying is go ahead and learn it now so that you have it down pat for later. So if x squared plus b times x is a binomial, if you add, and b is a real number, if you add b over 2, the quantity squared, which is the square of half the coefficient of x, then a perfect square trinomial will result. So what does that mean? X squared plus bx plus b over 2, the quantity squared, turns out to equal x plus b over 2 squared. It's really pretty cool and useful. So let's check it out. First step, we're just going to learn the mechanics. We need to find out, what is the b over 2 squared, all right, for each of these expressions, and then I'll show you what the equivalence is. So we won't be writing equivalent expressions because we won't be balancing anything out, but this is kind of the first baby steps to completing the square. So here we go. In this case, we have, do you guys see that the b is 2? So b is 2, which gives us b over 2 squared is going to be 2 over 2 squared. So this is the b we're talking about. And that, of course, is 1 squared, which is 1. So this is what we do with it. X squared plus 2 times x plus you put what was being squared in there. Actually, you get this here. Plus 1 is equal to this binomial being squared. So it's actually pretty cool. So once you have that b over 2 business figured out, so here our b over 2 ended up being the 1 right here. So you just put whatever is being squared in here to the binomial that's being squared. And I've been showing you a lot, so I mean, hopefully you've got what's happening, with the factoring and the factoring and all that stuff that we've been working with. Hopefully this shouldn't be too much of a stretch for you. So in this case, our b is actually, I'm going to keep the sign with it, is actually negative 12. Okay. So b is negative 12. So we're going to have negative 12 over 2 squared. And what is that? That's negative 6 being squared, and negative 6 being squared is a positive 36. So this was our b, and this here is what the b over 2 simplified was. So what the end result is that x squared minus 12x's plus 36 is equal to x minus 6, the quantity squared. And that was from here. All right, and last one. We have our b is 5. So we have 5 over 2 squared, which is 25/4. So what we have is x squared plus 5x's plus 25/4 is equal to x plus 5/2 squared. So we had a positive 5/2 here, so we didn't need to adjust the sign in the middle. Okay, so solving quadratic equations by completing the square. So what we have the benefit of here is that you've got an equation, so you can add the same thing to both sides, divide the same thing from both sides, etc. So here we go. If a is not equal to 1, remember a is the coefficient of your squared term. You divide both sides of the equation by a. You isolate the terms that have x's in them. So you isolate the x squared plus b times x. You add b over 2 squared to both sides of the equation. You factor and simplify. Apply the square root property, solve, and check your solution or solutions in the original equation. So again, I'm going to leave the checks to you this time, so that you don't get bored in the lecture. All right, so here we go. What do we need to do first? Good. We already have, a 1 in front of the x squared term, an implied 1 there. So what we need to do is we need to get that 2 over to the other side. So I added 2 to both sides of the equation. Now, what's my b? Good. b is 8. Right. b is 8. So b over 2 squared is 8 over 2 squared, which is 4 squared, which is 16. So you got to, figure out what you're going to use on each side here. On the left side, okay, we're going to be factoring the left side of this bad boy. So the useful thing to add to the left side is this part. So plus 4 squared. So that's what we add to this one. But 4 squared is 16, so we're adding 16 to the right. So the stuff you see in red, those are equivalent. So I've balanced the equation. Now, the cool thing about this is, once you do that, you know exactly what to put here, what it factors as. That 4 comes here, and it's positive, so you have a positive here. And you get x plus 4, the quantity squared, is 18. Now, applying the square root principle, we have x plus 4 is equal to plus or minus root 18. Now, there's a perfect square in there. 9 is a perfect square. So x plus 4 is plus or minus 3, because, 3, the square root of 9 is 3 times root 2. And isolating x, we get negative 4 plus or minus 3 root 2. So again, our solution set would be, you can either separate them out, or you can write it as negative 4 plus or minus 3 root 2. Okay? All right, next up, again, we're good with the coefficient in front of the squared term, but we do need to get that constant to the other side of the equation. So if I add 5 to both sides, I get this equivalent equation. Now, what's my b? Good. b is negative 3 in this case. So b over 2 squared is negative 3 over 2 squared, which of course is 9/4. So on the left side, we're going to use this one, and on the right side, we're going to use the 9/4. So we'll be adding negative 3 over 2. Let me make some more room here. We'll be adding negative 3 over 2 squared, which is equivalent to adding 9/4. When we factor the left side, that gives me x minus 3/2. Again, we put exactly down what's being squared. Now I need to get a common denominator. So if I multiply that 5 by 4 over 4, that's 20 plus 9 all over 4. So we get, and this, my apologies, is squared. So x minus 3/2, the quantity squared, is equal to 29/4. Square root both sides. I've been doing that in green, I think. Square root both sides. We get x minus 3/2 is equal to the square root of 29 over 2. So if you can simplify a radical, you need to go ahead and do that. So isolating x, x will be 3/2. And that was still plus or minus, my bad. Plus or minus the square root of 29 over 2. Notice they have a common denominator, so you're going to want to make one happy fraction. So x is equal to 3 plus or minus root 29 all over 2. So our solution set will be this here, or you can write it as with the plus or minus sign. Okay, so here we go. Part C, we need to do a little work with here. If I were to multiply both sides of the equation by 1/3 or divide each term by 3, whatever your preference is, we would get x squared minus 2x is equal to negative 2/3. So now my b is good, negative 2. So b over 2 squared is negative 2 over 2 squared, which is negative 1 squared, which is 1. So again, this part we'll use on the left side and the other part we'll use on the right side. So we have plus negative 1 squared on the left, which is the same thing as adding 1 because the negative goes away in the squaring. And then when we factor this guy, we get x minus 1, the quantity squared, is equal to positive 1/3. Negative 2/3 plus 1 is 1/3. Using our square root property, we have x minus 1 is equal to plus or minus 1 over root 3. But we can rationalize that. Your book is going to be looking at rationalized results. So we would get x minus 1 is plus or minus root 3 over 3. Isolating x, we have 1 plus or minus root 3 over 3. We want to get one happy fraction. So multiplying the 1 by 3 over 3, we have x is equal to 3 plus or minus root 3 all over 3. And our solution set will either be 3 minus root 3 over 3, 3 plus root 3 over 3, or 3 plus or minus root 3 all over 3. Okay, well, if you feel confident, as always, at any time, you can go ahead and try these on your own. Otherwise, just follow along. So here we go. Again, we need to get 1 in front of the squared term. So I'll do that first. I'm going to multiply both sides by 1/4. So I will get 1x squared minus 2/4 is going to be 1/2 x, and then plus 5/4 is equal to 0. So getting the terms that have x's in them on the left and the constant on the right, I have this. Now let's figure out what's my b. b is negative 1/2. So in this case, instead of b over 2, or do you see that b over 2 squared is the same as 1/2 times b squared? Are we good there? Which is, in this case, will be 1/2 times, what did we have? Negative 1/2 squared which is negative a quarter squared, which gives us 1/16. So on the left side, we'll be using the negative a quarter, and on the right side, we'll be using the other version. So negative a quarter squared is equivalent to 1/16. So let's go ahead and do that. I'm adding negative 1/4 squared to the left, and I'm writing it as adding 1/16 to the right. Now I'll be needing to get a common denominator on the right side. So let's see what we end up with. On this side we'll have x minus a quarter squared equals, do you see we'll get negative 20 plus 1 all over 16? So we'll have x minus a quarter squared is equal to negative 19/16. So now we use our square root property and we get x minus a quarter is equal to plus or minus, we have a negative, so we're going to have an I. So we'll have a root 19 over 4 for the 19 over 16 part times I. So when I isolate the x, I'll have 1/4 plus or minus root 19 over 4I. And keeping it in that format because of the a plus bi format for complex numbers, we can present our solution set two ways. We can write it as 1/4 minus root 19 over 4 times I, comma 1/4 plus root 19 over 4 times I, or the fast way, 1/4 plus or minus root 19 over 4 times I. Either one is fine with me. Okay, how we doing? All right, so here we go. This one is leading into some application problems. So, formula for compound interest. Formula for compound interest. So suppose that an amount of money, P for principal, is invested at an interest rate R, compounded annually, which means once a year, which is kind of unrealistic. In chapter 12, I believe we'll learn a more realistic formula. In T years, the amount A, or the ending balance in the account, is given by the formula A is equal to P times 1 plus R raised to the T. So let's look at this problem. So for this one, since we've been focusing on quadratics, I want you to make an adjustment here. Instead of after 3 years, change this to after 2 years. Okay, 2 years. This one. So let's see what we have. So you invested $4,000 in an account whose interest is compounded annually. So that tells us we can use that formula. Actually, let's write it. A equals principal times 1 plus rate raised to the time. So after 2 years, the amount or balance in the account is $4,300. Find the annual interest rate. So here we go. Another thing I wanted to write into this problem is we're going to round to the nearest hundredth of a percent. Okay, so let's identify what we have. We invested 4,000. That's going to be the principal. So P is 4,000. T is good, 2, because T's in years. And the amount at the end of that time, A, is 4,300. So what is unknown here is R. So let's plug our stuff in. So 4,300 for A, 4,000 for P, 1 plus R raised to the 2, because T we said was 2. All right, well, we want to isolate the squared quantity. So I'm going to go ahead and divide both sides by 4,000. So that reduces to 43/40 is equal to 1 plus R squared. Using the square root property, we will get plus or minus. Now the square root of 43/40 is, I went to 4 digits, so 1.0368, because it's not in terms of percentage yet. And that's equal to 1 plus R. Now, we're going to throw out this negative, because do you see we'll be taking away 1 from each side? A negative further decreased is going to be negative, and it doesn't make sense to have a negative rate. So we're going to work with that positive value. So if I subtract 1, I'll get 0.0368 is equal to R. And so if you make that a percentage, you get 3.68% is R. And that was rounded at that point. Right? So we can answer the question in words. The annual percentage rate is approximately 3.68%. And we're done. Okay. The Pythagorean Theorem, you may have seen this before. What you have going on with this guy is you're dealing with a triangle, a right triangle, so it's got a right angle. And each of these are considered legs. And this is and usually you call them A, B, C. And this here, this length, is the hypotenuse. So the sum of the squares of the lengths of the legs, my bad. The lengths of the legs of a right triangle equals the square of the length of the hypotenuse. So if the legs have lengths A and B and the hypotenuse has length C, then you get A squared plus B squared is equal to C squared. And then you can go ahead and solve it using, the square root property. So let's look at an example. The doorway into a room is 4 feet wide and 8 feet high. So imagine taking a circular tabletop through this doorway. You can tilt it, right, a bit to kind of try to get it fitting through. So we want to figure out the diameter of the largest circular tabletop we can take through the doorway diagonally. So if your doorway, looks something like this, and then imagine, your table is fitting through like this, and this here is going to have a right angle, right? Because it's a doorway, it's supposed to be square. So this here, it would be like your A, B, C situation. Well, we know the height is 8 feet. We know that the width is 4 feet. So we're looking for this length here, right? The gray length. So you just set it up. I mean, a squared plus b squared equals c squared. A is 8, so 8 squared plus 4, which is b, 4 squared, equals the diameter squared, which we let be c. So we get 64 plus 16 is c squared. 80. Now be careful, you can't just, since there's a plus sign, right, you can't start square rooting here. Right? Simplify as much as you can before you square root both sides. So 80 is c squared. Now we can use our square root property. 80 is 16 times 5, so we can pull out a 4. So we'll get plus or minus 4 root 5 is equal to c. But this is length, right? So we throw out the negative result because it doesn't make sense for a length to be negative. So let's answer the question in words. The largest, we'll just reword it, the diameter of the largest circular tabletop that can be taken through this doorway diagonally is 4 root 5 feet. Okay. So it'd be a little over 8 feet if you got an approximation. There. So remember, to approximate, you would do 4 times root 5. All right. So next up, we have the distance formula. So the distance formula is, it's kind of cool. It's really, you just use the Pythagorean theorem. Let's say that, you got an ordered pair here and here, right? So this one, let's call this one x1, y1, and this one can be x2, y2, first point, second point. Now, the shortest distance between 2 points is a straight line. So what ends up happening, it's pretty groovy. You've got this going on. You can actually, if you think about it, you can actually make a right triangle, right? So then this length here is going to be the difference in the y values, right? Because if we were to take a look at this ordered pair right here, this ordered pair is going to be, it's going to be x2, y1, right? So the difference is going to, the length here is going to be the change in the y values, right? So that would be, I'll do it in black, y2 minus y1 is that yellow length. And over here, Do you see the difference between these x values is going to be x2 minus x1. We'll do that one in blue. So this length is here. So think about it. We would have x2 minus x1 is like our a, one of our legs. So we square that. We square y2 minus y1, and we get this distance d squared. So then, applying the square root property, and only considering the positive because of the fact that length is positive, you end up with that. And that is our distance formula. Usually you see the d first. So the distance d between the points x1, y1 and x2, y2 and the rectangular coordinate system is d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 the quantity squared. So go into an example of using the distance formula. We've got a couple here. Why don't you go ahead and try A. Pause the movie, give it a shot. All right, let's see how you did. So the distance d equals the square root of. So x2 is 8, x1 is 5, so we'll square that difference. And then y2 is negative 2, y1 is 1, and we square that difference. So we actually get root 3 squared, oh that's funny, plus negative 3 squared. And then we'll get root 9 plus 9 is 18. So simplifying that, remember 18 is 9 times 2, so that's going to be 3 times root 2. And then that's in linear units. All right, how'd you do on that one? Awesome, I knew you could do it. So next up, this one's a wee bit more complicated. So our first one, our x2 is negative 1 root 3 minus 2 root 3's. We're going to square that. Y2 is 5 root 6. And then we're going to subtract 1 root 6 from that and square that difference. So d is the square root of. So we'll get negative 3, because negative 1 minus 2 is negative 3. Root 3, they have like radicals, and we'll be squaring that. And then 5 minus 1 is 4. Root 6, those are also like radicals. So d will be, so remember, negative 3 times negative 3 is 9. Root 3 times root 3 is 3. 4 times 4 is 16. Root 6 times root 6 is 6. So this distance will be root 27 plus, that gives us, I believe, 96. So d is the square root of 123, which is what, 3 times 41, so that there's no perfect squares in there. So we're done. Okay. The midpoint formula. So consider a line segment whose endpoints are our old friends x1, y1, and x2, y2. the coordinates of the segment's midpoints will be. Now this one, it's just the average of the x values is going to be the x coordinate. So remember, when you average, you sum them up, and then there's two things being summed up, so divide by 2, and the average of the y's. And that's it. So, just got to be careful when you're combining everything. And you'll have the midpoint for the first one is so one big ordered pair, so we'll have 10 plus 2 over 2. That's the average of the x coordinates. The average of the y coordinates is 4 plus 6 over 2. So the midpoint will be 10 plus 2 is 12. 12 divided by 2 is 6. And 4 plus 6 is 10. 10 divided by 2 is 5. So the ordered pair is 6, 5 is the midpoint for this guy. Okay, over here we'll have midpoint is, remember, fractions are your friend. So the average of negative 2/5 and negative 2/5, you might have already seen that you're going to get negative 2/5. But just in case, we can walk through it. Negative 2/5 plus negative 2/5 all divided by 2. And then we'll have 7/15 plus negative 4/15 all divided by 2. So the midpoint is, we'll get, remember, if you're dividing by 2, it's the same as multiplying by a half. So we'll get negative 4/5 times a half for our x coordinate of the midpoint. This one will get 3/15 times 1/2. And we can simplify a little bit. This 2 divides out some of the 4, and the 3 divides out some of the 15. So our end result for our midpoint will be, oops, the ordered pair. What a surprise! Negative 2/5. And then we'll have 1 times 1 over 5 times 2, so we'll get 1/10. And we're all done with 11.1. Make sure and do your homework set as soon as you can, and have a fabulous day.